All right, here we go. So today is November 7th. And we're doing a little more factoring today. So yesterday you learned factoring sum or difference of cubes. Definitely see that on the test. And also factor by grouping. Again, you'll see that on the test. And this is factor by grouping. When we have 1, 2, 3, 4 terms, we can do factor by grouping. And so we're going to split these in half. And factor by grouping is just greatest common factor a bunch of times. So we're going to look at the first two terms and say, what do they have in common? X squared. And if you take out the x squared, what's left behind? X minus. There always has to be something left behind. 1. It is 1. Yes. How do you know if you did it right? You distribute. You just distribute and check. And it's definitely something you can do in your head, but x squared times x gives me the x cubed, and x squared times -1 gives me negative x squared. It's worth taking a second. Then we look at the last two terms and say, hey, what's the GCF? Positive 16, or should we take out the negative 16? The negative. Yeah, you always want to take out whatever the sign is. Negative 16. And then, again, if we take out negative 16, what's left behind? X, and then -1. And again, just double check by distributing to make sure you did it right. So negative 16 times x gives me negative 16x. Negative 16 times -1 gives me that positive 16. So it is perfect. And then we do the GCF again, because now we see that we have two terms and they have a factor in common. What do they have in common? X minus 1. And when we take out that one thing they have in common, it's just one thing, not two of them, it's just one of them, one thing in common. What's left behind? The x squared and the -16. That's the factor by grouping process, but this one actually factors a little bit more. X squared minus 16 has a special name. Does anyone know what the name is called? Difference of squares. It's difference of perfect squares. Difference meaning, hey, there's a big subtraction sign there, and x squared is a perfect square, and 16 is a perfect square. Today, your job is looking for difference of squares. We're factoring a ton of difference of squares today. And whenever we see difference of squares, it's going to double bubble a little bit further. What times what gives me x squared? X times x. Last times last has to give me negative 16. What times what gives me negative 16? -4 and +4 give me negative 16. And then we still have this x minus 1 out in front. All right, this is what we call factored completely, and this is what we're doing today, factoring as far as we can go. So this is factored, where we see all of these bubbles, but now what we need to do is actually solve. How do you solve for x when you have bubbles? We've done this, but it's been a while now, before fall break. Do you remember we set each bubble equal to 0? So we get x minus 1 equals 0, and x minus 4 equals 0, and x plus 4 equals 0. We set each bubble equal to 0, and that gives us equations that we can then solve, isolate x. How do I isolate x here? Add 1. So we add 1 to both sides, and we get x equals 1. How do we isolate x here? Add 4 to both sides, and we get x equals 4. And the last bubble, we get x equals -4. These are the solutions for x, also known as the zeros or x-intercepts. Ladies and gentlemen, this is what you're doing tomorrow, all right? You are going to have a little bit of a review day where you're going to practice these factoring methods that we worked on yesterday and today, just like this, factor by grouping, finding the zeros, and then we're going to graph. And so you're going to make a little sketch. These are the x-intercepts. There's an x-intercept where x is equal to 1 on the x-axis, where x is equal to 4 on the x-axis, and 1, 2, 3, negative 4 on the x-axis. We've done a little bit of factor, solve, and graph before, and so we want to make a little curve that passes through these three intercepts. This is a positive x cubed graph, and what that means is it's kind of got a positive slope overall. It's going to start low and end high. So we're going to start low and pass through each zero in a nice smooth curve, just like that. So all of our positive x cubed functions are going to have this nice little squiggle. Okay? And this is what you're doing tomorrow. So I hope you wrote this down. I'm not going to be here, and you have a worksheet. And I will do 3 problems on the board. You can copy those problems down on your worksheet. So they're 3 problems from your worksheet. And they'll, again, it just goes right through this. Same exact thing. Factor, solve, and graph. It's a really good connection between the factors and the zeros and the x-intercepts on the graph. Okay? All right. So today we're trying to factor completely today, which involves a lot. The first thing we want to do is really just always look for greatest common factor first. Example 1, factor the polynomial. We are factoring, double bubbling if we can. So we're going back to, hey, we've done this before. How do you double bubble? So hopefully you'll remember. All right. So the rule number one is greatest common factor first. Rule number 1, GCF. Always look for the greatest common factor. So here we have a function, f of x equals 9x to the 4th minus 36. I want to try to factor this polynomial. Does it have a GCF? Nine, yes, I can take a 9 out of both of these things. So we're going to factor out a 9, undistribute a 9. When I take the 9 off, what's left over? X to the 4th minus 4. Okay. So how do you know if you did it right? Distribute, sure. 9 times x to the 4th gives me 9x to the 4th. 9 times negative 4 is negative 36. Now we need to factor further. This has a special name. What's that special name? Difference of squares. Difference of squares. It's called difference of squares because it's got a big giant difference sign, subtraction sign, and what we start with is a perfect square. What times what is x to the 4th? X squared times x squared. And what times what is 4? 2 times 2. Those are perfect squares, and those are always going to factor further. So we factor this a little more. First times first gives me the first thing. X squared times x squared gives me x to the 4th. And last times last gives me negative 4. What times what is negative 4? Negative 2 and positive 2. And this 9 is just hanging out in front. He comes along for the ride. Is this x squared minus 2 difference of squares? No, it is not. Is 2 a perfect square? No, it is not. So this is fully factored. g of x equals x to the fourth minus 10x squared plus 24. First rule, is there a greatest common factor? No GCF here. And so then we go straight to try to double bubble. And the pattern for double bubbling, first times first has to be the first thing. What times what is x to the fourth? X squared times x squared. And then last times last has to be positive 24. What times what is positive 24? Negative 6 and negative 4, positive 6 and positive 4. There's lots of options, negative 12 and negative 2. Which one do we want? Negative 6 and negative 4. Very good. I'm going to do negative 6 and negative 4. Negative 6 and negative 4. How do you know if you factored correctly? What should you always do? Check the rainbow. The rainbow is where our middle term comes from. When I check the rainbow here, x squared times negative 4 is negative 4x. And negative 6 times x squared is negative 6x squared. The combination of those, negative 6 and negative 4, is where that negative 10x squared comes from. So that middle term comes from the rainbow. Please remember that. Now the question is, are we done? We're not done because I wrote g of x again. Why aren't we finished? X squared minus 4 is difference of squares. So that factors further. So I'm going to expand that again. What times what is x squared? X times x. And then what times what is negative 4? Positive 2 and negative 2. What do I do with this x squared minus 6? Can I factor him? He's different. 6 is not a perfect square, yeah, so he just comes along for the ride. And this is fully factored. This is as far as we can go. You always want to double check if you have something that's being squared, can it go further, right? If it's x to the first power and x to the first power, that's as far as it's going to factor, so those are definitely done. But today it's all about, can I factor more? Can I factor more? All right, 2 more. Letter C, 2y to the 5th minus 18y. What's rule number 1? GCF. Is there a GCF here? A 2 and a y. Very good. So we're going to take out the 2y. What's left behind when I take out the 2y? Minus y to the 4th minus 9. Okay, good. All right. And then, again, you can check by distributing. Y times y to the 4th is how we get that y to the 5th. And 2y times negative 9 is negative 18y. Are we done? No. What is this called? Difference of squares. Difference of squares. So that's going to double bubble again. What times what is y to the 4th? Y squared times y squared. And then last times last has to be negative 9. What times what is negative 9? Positive 3 and negative 3. Good. And what do I do with this 2y? Bring it down. Yeah, just bring it along for the ride. Can I factor up that one? Can I factor that one? It's difference, but is it difference of squares? No. All right, so that's fully factored as far as we can go. All right, this last one again, factor, solve, and graph. Again, this is just like what you're going to see tomorrow. We're going to not only bubble everything, but then find the x-intercepts and then graph them. So factor, solve, and graph. So this is a trinomial. Rule number 1, is there a GCF? No GCF. So then we're going to go ahead and try to double bubble. So what times what gives me x to the fourth? X squared times x squared. And last times last has to give me positive 36. What times what gives me positive 36? Negative 9 times negative 4, positive 9 times positive 4. Lots of choices, negative 12, negative 3. Why do we want negative 9 and negative 4? Yeah, that's for the 13. And again, that really comes from when we check the rainbow. So remember to check the rainbow whenever you're double bubbling. Negative 4x squared and a negative 9x squared is where that middle term comes from. Are we done factoring or does it go further? Yeah, we have lots of difference of squares here. Both of these go further still. So x squared minus 9 is going to double bubble into what? X minus 3 and x plus 3. Very good. X times x is x squared. Negative 3 times positive 3 is negative 9. And then again, we can double bubble the x squared minus 4. How does it factor? Yeah, x plus 2 and x minus 2. X times x gives me x squared. Negative 2 times positive 2 is negative 4. So this is fully factored completely. How do I actually solve for the zeros? How do I find the zeros? Yeah, you set them all equal to 0. And you can certainly skip this step, I think. X minus 3 equals 0. This is the process. We would actually add 3 and get x equals 3. So can I go directly there? And so we would get x equals negative 3. Here we would get x equals negative 2. And here we would get x equals positive 2. So these are the zeros or x-intercepts. And so I'm going to make a little sketch. This is a different function. We have negative 3 and negative 2 as an x-intercept, and positive 2 and positive 3. 4 intercepts. This is x to the fourth. X to the fourth is in the classification where it's an even power, and even powers look like parabolas, where they're either both arms up or both arms down. Do you think this is going to be both arms up or both arms down? Both arms up. It's a positive x to the fourth, and that means both arms are going to start and end way up high, and we just have to pass through those zeros. Just like that. It's like a giant W. I don't care how high the mountains go and how low the valleys go. This actually peaks out at 36. So at y-intercept is 36. If you have a graphing calculator, all of the problems tomorrow you can graph on your graphing calculator. So hey, minus 13x squared plus 36. And watch what happens. So this is all I care about, an easy sketch. But you can see, I can't see the top of the curve because it's way up here at 36. All right? But we just want the general idea. And that's good enough. Okay? The important part here is that you can see it goes through negative 3 and negative 2 and positive 2 and positive 3. So that those x-intercepts match. So you did an excellent job. Do you guys have any questions for me? All right, greatest common factor, check that first. And then double bubble and lots and lots and lots of double bubbling today, okay? In case you're curious, number 54 is on the board. Yeah, grab the hot pass, please. Okay. You know, super close, but the page can make it to 16 over. That is just key. So, and then again, so this is difference of squares. This also difference of squares. So a little bit further. I would leave it like that. It's different with squares. And so do this way. First time squares, I'll see